An acid is defined as any kind of compound that is considered a proton donor, right? So that's going to be able to release an H positive ion into the environment. And anything that gives that off in a water solvent is going to be acid. Anything that is a proton acceptor, if it takes this in, we call that a base, right? So this is just a very quick way to look at how different kinds of reactions can take place in the body. And there are probably one reaction that is extremely significant, and it's related to CO2 and carbonic acid and carbonic ion. Way that this works is that you have an optimal pH range that you want to strive for, which is pH of 7, right? And pH is a measurement of the number of protons, otherwise the acidity of an environment. When you increase protons, the pH goes lower. So just to make sure you're aware, low pH means high protons. High pH means low protons. So that's a relationship you need to be very clear on. So when a solution has more hydroxide, OH, ions than a proton, then this is called a base because it's going to take up some of the protons, and you're going to see a pH that's higher than 7. So pH scale ranges from 0 to 14, with 0 being the strongest acid possible. The pH of 2 is your stomach acid, which is extremely toxic and corrosive. That's why you hear about ulcers and potentially having GERD, gastric esophageal reflux disease, which can cause burning inside the lining of your small intestine or esophagus and cause ulcers and potentially even cancers. And then pH is calculated, just a little expression of log of 1 over the concentration of H positive. We're not going to do any math in this course, but just make sure you are aware that a low pH corresponds to a lot of protons. So buffers are significant in the human body. And this is where there's one reaction, if I had to tell you, that you would want to appreciate or even at least be comfortable with. That's going to be when you see the CO2, carbon dioxide, right, combines with water, and that will then create a reversible reaction to create something called carbonic acid, H2CO3, because it's all balanced, and then it creates the bicarbonate ion. All right, and that ion, bicarbonate, HCO3 minus, basically comes at a cost of protons. So if you look at this reaction that are on the board, and you just take a look at it, right? You have CO2 on one side and water, and if you hold your breath, CO2 increases, it's going to cause your body to now shift this reaction towards the carbonic acid. And you have an enzyme found in our red blood cells that carries this reaction out, and it's called carbonic anhydrase. It's also found in your kidneys. But this enzyme will quickly take CO2, which is relatively toxic, you don't want that to build up in your body, to something that's a little bit less toxic called bicarbonate, right? HCO3 minus. That's the ion that I'm putting a square next to. And then this also creates protons. So the question to ask you is that if you were to hold your breath and not expel CO2, what happens to the acidity levels of your body? Well, the answer to that is your protons increase, so you become more acidic. So when your pH level drops below 7.35, this is a condition referred to as acidosis. You can have two versions. One is respiratory based, and then one is metabolic based. You can also have a condition where it goes above 7.4, which is going to be called alkalosis. And is one better than the other? I believe you always want to have a consistent range to be at. You don't want one day to be extremely acidic and one day to be extremely alkalinic, because your body is not going to be able to adjust as quick. So having a moderation between 7.3, 7.4 probably is going to be the best. Unless you're like changing your diet every single day and you go vegan one day and then you go hardcore Atkins one day, chances are your body's usually going to want to be in that homeostatic range.